Good morning, sir.
I hope everybody could hear.
Fine, thank you, sir.
Okay, that's good. Good to. How has your week been? Hope you've had a good week, yeah?
Yes.
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 Okay. Okay, last time we looked at, we went through the topic of heat expansion. Sorry, you can hear this some echo. So we went through the topic of expansion, and we said expansion results in increasing length and also in the size of an object. Basically, we looked at heat and temperature. And we said though the two are not the same, they are closely related. In that when we lose heat, temperature increases. When we gain heat, when we lose heat, temperature decreases. And when heat is gained, the temperature increases. Though there's no direct way of measuring heat. We remember the definition of temperature. What is temperature? Are we there?
Coldness of a place.
The degree of hotness, of coldness of a body. We say a body because it's not limited to just a place. Okay. What is heat?
Heat is a form of energy that flows from a region of high concentration to lower concentration.
Concentration or temperature?
Temperature, sorry.
The heat that is transferred between 2 points owing to a temperature difference. Okay.
Yes.
What is the measure of increase in length of a body of a solid when it's heated?
Linear expansivity.
Good. And in terms of expansion, what expands most between the three states of matter?
Gases.
What expands most?
Gases
expand. Gases expand the most. And why do gases expand the most?
Pardon?
Why is it that gases expand more than solids and liquids?
Because during heating, since states of matter are heated or temperatures to increase for them to expand, gases have very weak intermolecular forces holding them together. So it takes a rather low temperature, or the heating doesn't have to be that intense in order to break the intermolecular forces.
Well, it's because gases have very low intermolecular forces, and therefore they move very freely. Definitely, when we heat, the kinetic energy increases greatly, and that way they're able to move. Okay.
Yes.
What are some of the effects of expansion, especially in gases? Is there one effect that you can single out that is as a result of expansion gases? Okay, what is the land breeze?
Land breeze is the cool winds that come from the land and end up cooling the surface of the water body.
The movement of cooler
from
surface of the sea. What causes this land breeze? Or how does it occur? How does land breeze occur?
Since the water bodies are heated faster than land, air on the surface of the water body will rise, and cool air from the land will come in to fill the space that was left behind, and this creates a cycle that will form the land breeze.
Okay, good attempt. Is it really about heating? And it's during the night, isn't it?
Yes.
So what happens during the night?
Because
Yeah. During the night, what happens?
the water body will lose heat faster than the land.
Yeah. Which loses faster? Is it the water body or the land?
The land.
It is the land that gets cooled faster than the wind, than the sea. Therefore, we have warm air rising from the sea surface and cool air flowing in from the land to replace the air that has risen, isn't it? And of course, during the day, we have the reverse. And what happens during the day?
The land heats up much faster than the sea.
The land gets heated faster than sea. So we have air rising from the land. And of course, we have cool air moving from the sea to replace the air, hot air that has risen, isn't it? Okay. Now today I want us to look at heat transfer. Heat transfer. And as we think of heat transfer, of course, these things we experience on a day-to-day basis. Sometimes we warm ourselves on a fire. How does the fire get from us, from the fire to us?
Radiation.
And how do we get the sun, heat coming from the sun all the way to the earth? Okay. And possibly by the end of this topic, we expect to have a few things that we should be able to do. A few things that we should be able to do. And one of the things, some of the objectives that we want to look at is that we should be able to state the difference between heat and temperature. I guess you already get but isn't it? We should be able to state and explain the modes of it. We should also be able to describe experiments to illustrate factors affecting heat transfer and explain applications of heat transfer. And with that, we have heat and temperature, modes of heat transfer, and factors. So heat transfer is exchange of bodies or parts of the same body at different temperatures. That is heat transfer. And the three modes of heat transfers are there, mainly convection, radiation, and conduction. Of course, we know what temperature is. Temperature again. What is temperature?
Temperature is the degree of hotness or coldness of a body.
Degree of hotness or coldness of a body. And of course, it's measured in kelvins. The SI unit is the Kelvin. It's also measured in degrees Celsius, but the SI unit is Kelvin, yeah? And we use a thermometer to measure temperature.
Sure.
Yes? Of course,
Yes.
Is somebody asking something?
I was asking here, is it heat transfer only takes place in the same body?
No, it says between bodies or parts of a body. You see that skin of scared? It is not between, it can be between. It is not between, it can be between two separate bodies. It can be within the same body. Okay?
Yes.
Of course, we can have all the three processes occurring at the same time. That's what he's saying, occurring simultaneously. We can have them occurring simultaneously. And of course, as we say, it is not an issue for one mechanism to overshadow the other two. For example, when you look at conduction, it is basically the form of heat. And of course, you don't expect that we will have convection in solids. Of course, with liquids, though they are poor conductors, we can have a little bit of conduction, and also we can have the major or the predominant form being convection. Okay?
Yes.
Of course, we know heat is. What is heat?
The form of energy that flows from a region of high temperature to a region of low temperature owing to a temperature difference.
It's, of course, when you say high temperature to low temperature, then you don't need to say owing to a temperature difference, yeah?
Yes.
So we have something showing three forms of heat. That graphic is about conduction, is about radiation, and there is the kettle conduction with convection, yeah?
Yes.
So heat is transferred by three processes or three modes of heat: conduction, convection, and radiation. And conduction is the transfer of heat. For example, when you are cooking on the fire. So what happens? The fire heats the pot, then the pot conducts heat to contents inside. Okay? Because convection, exchange of hot and cold molecules in form of currents, and that's a process through which liquids become heated. And of course, you have radiation, which is the fastest mode of heat transfer, because heat is transferred in form of an electromagnetic wave, usually in form of infrared radiation. And that is how we get heat from the sun. Okay, conduction. So you have a solid. Within the solid, the only method of heat transfer is conduction. It mainly occurs in solid. And what happens is that you have, when the heat, there's one end of solid, and you remember the kinetic theory of matter. The solid is made up of particles that vibrate about their mean position. So when you heat, the particles vibrate, and in the process of vibrating, they knock against each other. And this way heat is transferred from one particle to another until the heat reaches the other end. Of course, there's also the general belief that the majority of the heat is conducted through the free electrons, especially in metals. And these are said to be the major contributors of heat transfer being transferred. Okay?
Yes.
So you have a diagram there showing, of course, just trying to explain what I've just said about particles colliding and all that. So the atoms collide with coulomb, transferring some of the energy. Of course, if there is that, physical contact may not occur in a vacuum. With the aspect of free electrons, tries to explain us why good conductors of electricity are also good conductors of heat. And of course, you have materials like gold, silver, copper, which are good conductors of heat. We have glass, asbestos, paper, which are poor conductors. And we refer to those that are poor conductors as insulators. Of course, we need to know how heat is transferred, and we can compare the different materials and how they conduct. We can compare how different materials conduct. So metals are good conductors. And insulators or non-metals are generally poor conductors of heat. Okay? So the ability of a material to conduct heat is known as its thermal conductivity. Thermal conductivity. Okay? Of course, we can compare thermal conductivities of different materials. we can compare thermoconductivities of different materials. And to compare thermoconductivities, what we need is to have different materials of equal length and thickness. Equal length and thickness, and heated from the same source. Because what you can do is that you can have some wax at the end of the material. Then we observe which wax gets of the material first. Okay? So they have different materials having different conductivities. And you can compare conductivities of materials. Of course, the rate at which heat is conducted depends on a number of factors. Depends on a number of factors. One of the factors that is the length of the material. And to find out how length affects conductivity, we use the same material, the same thickness, but different lengths. We use the same material,